Right, the key in solving trigonometry is not to think of the problem, because the problem will confuse you. Rather think of the basic concept esiqale ngawo ukukhuluma ngawo. So this is going to help us to understand whatever problem that we are doing. This is the key to any problem with trigonometry. In this case, we are proving that the left-hand side is equal to right-hand side. So my eyes become a very special tool. I've got a left-hand side as well as the right-hand side. Which one am I familiar with? When I look at 75, it's not even a special angle. It's just an angle, 75, and there's nothing I can do with it. When I look at this one, I don't know what it is, but there's something that I can recognize. I know where do I find square root of 2? I've seen square root of 3 somewhere. Where did I see that? I've seen that in special angle. When I use these two triangles, I can see square root of 2 and I can see square root of 3. That guides me into pushing me into using special angles. Can I represent this in a special angle form? Yes, I can. So how do I do that? So it simply means that I'm taking the left-hand side and I've got to prove that it is equal to that other side. What do we have this side? We've got cos 75, which I can write as a special angle in the form of 30 degrees plus 45 degrees. Remember, this must be exactly the same as that one. I should not change the value of that angle. 30 plus 45. It is exactly the same as 75. Right. Once I have a cos 30 plus 45, this is taking me somewhere else. Cos A plus B. Cos A plus B. It pushes me into compound angles. Now, I know exactly that now I'm going to be dealing with the compound angles. What is the rhythm that causes khulumengayo? So tell cos, sine. Remember, if I've got plus here, the sign will change. Cos start with C and change sign start with C. Sine, same sign. If I'm dealing with sine, I will keep the same sign that I have there. Sine start with S, and the same sign will start with an S. Cos start with C, change sign start with C as well. So the rhythm, I keep the rhythm. For sine, it is sine, cos, sine. The angle will follow each other respectively. Cos, sine. Right. What is it that we're dealing with here? We're dealing with cos. So the rhythm will go cos, change sign, sine. Let's do this thing. This then becomes cos 30 times cos 45, because we're dealing with cos, we change sign, C, which is minus cos, sine the first angle, which is 30 degrees, times, this is cos, sine. Khuluma nesibalo sakho, sine 45. This is what we have so far. Now, when we have it in that form, sekulula ukusebenza nayo. At the same time, remember, your eyes are still very important here. I look at it to try and save time, to try and not repeat the same thing. Remember, we said cos 45 is the same as sine 45. We did problems in that where we said, if I've got to sine 20, it is the same as what? As a cosine of 70, because this 2 will give me 90. If I've got sine 30, it's the same as what? Cos of 60, because this 2 will give me 90 as well. So if I've got to sine of 45, in this particular case, it is the same as what? Or cos of 45, because this 2 will give me 90 degrees. Right, so I know that whatever I worked in cos 45, I should put the same thing there in sine 45, because those two are the same. Let's do this thing. What is cos 30? You can use the calculator or you just use the diagram. Let's check cosine, cos of 30. Yes, this is cos 30. What is it that I got? I'm getting root 3 over 2. Square root of 3 over 2. Whether I use a calculator or I use my diagram, I will come to the very same solution. So it is quicker to use a calculator and it's acceptable in the examination. Right, this is times cos 45. Let's check what is cos 45. This is cos of 45. What do I get? I get square root of 2 over 2. Square root of 2 over 2. It simply means that on this one, I'm not going to go and do it on the calculator. I'm just going to cut this one here and paste it there. This is minus. What is sine 30? Sine 30 is 1 over 2 in my calculator. It is half times, sine 45 is the same as cos 45. So simply like cos 45. Let's just cut it and paste it here. This is going to give us a root of 2 over 2. All right. Remember, as I do this, I don't lose sight of what I want to get. At the end of the day, I want to have that. Right. So whenever I have something like this, I don't disturb it. Asambeni. This then will give us. All right, how many terms do I have there? Number terms out 2. We've got 2 terms there. This term 1 and this term. Our uniform number terms out 2. This is 1 term, this is 1 term. Separated by plus or minus sign. It's a term. If we've got to add our numerator and our denominator, subtract something, we do the same thing here. We add we multiply. It's easy, this one. 2 times 2, it's 4. 2 times 2, it's 4. Ah, there is 4 coming out now. It was hidden somewhere here. Now I can see it coming out to 4. All right, let's multiply the numerator. What is root 3 times square root of 2? It will give us square root of 6. What is square root of 3 times square root of 2? It will give us square root of 6. But do I have square root of 6 there? No, we don't have square root of 6. So let's not, this is in the form that we need. We do need square root of 3 and square root of 2 because we can see them there. So let's keep it as square root of 3 times square root of 2. Let's keep it in that form, square root of 3 times square root of 2. This is square root of 6, we know that. But we don't want to disturb what we want. Square root of 6, others must see just like square root of 6. They won't see it. It is the same as square root of 3 and times square root of 2. Let's move on the other side. What is 1 times square root of 2? It is square root of 2. Right. This is what we have now. We still have 2 terms. We've got this term and that other term. I can see what I want. I can see what I want. I don't disturb whenever I see square root 2. Whenever I see square root 3, I don't disturb those because that's exactly what I want. Let's move on. Let's look. It has the common denominator. Fortunately for us, this has the common denominator of 4, the common denominator LCD. We say 4 into 4 goes once, times our numerator. It's going to give us square root of 3 times square root of 2, of course, which is square root of 6. This is minus 4 into 4 once, times square root of 2, it will be square root of 2. Remember, I've been preaching this gospel that your eyes are the most important tool in your mathematics. So use your eyes. You've got the numerator there and the denominator. I already have what I need in which denominator I am. Now I use my eyes. I've got 2 terms on my numerator, this term and this other term. When I use my eyes, I don't calculate this, I don't think about it, I don't study it, I don't pray about it, I just open my eyes and see what is common on this term and on that other term. I see square root of 2 and square root of 2. We call that a common factor. Let me continue from this side. So what is a common factor in these 2 terms? It is square root of 2. If I take out square root of 2 here, what will I be left with? Square root of 3 minus square root. If I take out square root of 2, then I'll be left with 1. Because when I multiply this, I should get this exactly as it is. This is all over 4. Is this what we want? Yes, it is exactly what we want. So it is true that this side is equal to that side. Then you can conclude by saying, therefore, the left-hand side is equals to the right-hand side. So it is important that you don't think of the problem, but think of the basic concepts that will lead you into a solution. Thank you.